Pass My Exam podcast. The views and opinions are personal and unrelated to the opinions of my employer, Expedia Group. Please read this disclaimer carefully.
Like, take something simple like a percentile, right? Like, we'll do like percentile ranks because like they might ask.
Yeah, I know that.
Yeah. Like, I'm just trying to.
You mean confidence interval, right? You mean confidence interval, right?
Confidence interval. Yeah.
Yeah, I get it. That's interesting. Do you do this? You do this like in your everyday work, or is it like some specialized?
You kind of do a lot of things. It's just like a quick, way of getting intuition into the data to build your own knowledge. And then you have to translate that into a business question. I don't get requests from people saying, "Oh, I want, a Poisson XGBoost model, with this type of MAE, threshold." No, it's more like we have to remove out. We have a bunch of messy data. I need to see a report on it, and I want the result just in a spreadsheet. I don't want.
Wow. Okay. Yeah.
What's
I mean, yeah.
Is that like what's your modeling experience?
Okay, and then I work with like text data. I work with like unstructured data, like you do with. I have worked with text, etc. I've done NLP.
Okay.
Just tell you like one small commercial trick. Okay, so for example, I was just telling you there are a lot of parts that go into servers, right? Like laptops. Servers also have SSDs, HDDs, memories, processors, etc. Right? Like we are given the pricing team, so all of my team members used to price every part that Dell has. So they used to price every SSD, every HDD, and then like you have a custom config, and then you sell it to the customer.
Okay.
So, and then we used to procure these parts from different vendors, right? So the descriptions of the parts and like the part numbers were not like standardized. Some vendor may call it in this format, and some other vendor may call it in another format. Okay, the description of the part. Now, before you do anything related to pricing, you will need to know what that part is about. From the description, you'll need to identify what are the features of that part, right? So, like you take example of a processor, you need to know if it's like an Intel or an AMD, and then if it's how much gigahertz it has, what's the cores it offers. So, like all these features. So, once you have all these features, you'll know how to price it. What's the part basically about, right? So now, everyone in the pricing team, if they're doing list pricing or they're doing discounting or they're doing price comparisons versus HP or Lenovo or whatever, they need to have these features of these parts. And like how everyone was doing it, and they'll look at the description and they'll tell, okay, this is an Intel processor, 3.3 GHz, has 32 cores, whatever, this one, all these attributes. That's like a manual process. So like what my manager came up to me was with this problem statement that like a lot of people in the team are spending a lot of time on this. Everyone is doing the same thing, but we're wasting too many hours in a week doing this. So can you like try to build like a model or anything of that sort? So to kind of automate this using any data science technique. So then I had to just research a bit, and then I came up with like a project just before I left. So there were like two phases. So the phase one was you given a part description, and then I ran, if you know multiclass classification. that model will classify, based on the description, it will classify what bucket that part is into. So you just give it a description and it will tell you if it's an HDD or an SSD or a processor or a memory, just based on its description. So it's trained to do that. And I tried a lot of models with this, like think random forest, not logistic. I tried, and then I think I got the best accuracy with something called a linear SVC.
Oh, an SVC? What's an SVC?
Yes. Linear SVC, I think it's support vector something.
I've heard that random forests are very good for multi-classification problems because they naturally have different trees that fit the different classes.
So it's like, it depends on your problem statement. Sometimes your random forest may not give as good results as a plain regression. Sometimes simpler models are better and sometimes complicated ones. But SVC is a support vector classifier. So this is like, it's like a support vector, but it's for classification.
How did you choose the kernel?
What do you mean by kernel?
Like for an SVC, you have to set the decision boundary. It could be like linear, or it could be like a hyperbola.
What happens is you kind of get all your data in, and then it will fit a hyperplane that divides your data automatically. So there'll be like a hyperplane, like in whatever the number of dimensions of that hyperplane will be the number of classes you want. Okay. So you treat it as a non-linear model. You cannot imagine a parabola or anything because my number of dimensions are like multiple, right? I had SSD, HDD, processor, memory. So you can't imagine 5 dimensions here in your head. You can't imagine any parabola or anything because it's gonna take your data and based on the number of classes. So for example, I have 5 classes, it will be a 5-dimensional plane in which it's going to fit a hyperplane around your data.
But like a hyperplane, it's a general term. Like, it doesn't have to be straight. It could be convex or concave, right?
No. I don't think it will. It won't be straight. This is not a linear model.
Right. It's the shit gets really deep. Like it could be because many problems aren't linear. Like there isn't a linear solution. Sometimes like there's if there isn't a linear decision boundary or a hyperplane, like you could use like different types of curves.
So I think if I had spent a little more time tuning hyperparameters of random forest or any tree-based methods, I would have got the same accuracy. But the advantage with linear SVC is that it's faster.
What was like the Bayes error rate? Would you estimate?
Dude, I forgot the actual numbers now.
Yeah, that's okay.
But like, okay, if you just want the accuracy number, I think we were reaching 95.
Okay. Yeah, I always get a kick out of like when you try to explain accuracy, but what you really mean is like, area under the curve, AUC.
No. Accuracy in classifiers is on your test set, how many do you predict correctly?
I know, but that's kind of like BS sometimes because if there's an imbalanced classes, like I was just looking at that.
This data was skewed, right? I had had more SSD data than some screws or something, right? So we had to balance the class using some techniques. I think random oversampling or something like that I used, so that your classes are balanced. After that, if you've heard of TF-IDF, term frequency, inverse document frequency.
Term frequency?
TF-IDF, okay. So this was text data, right? So like this is where it gets interesting. So this based on the number of terms encountered overall. It forms vectors, basically TF and IDF. I mean, after this call, you can just Google what is TF-IDF. So basically, based on, it's gonna count, TF is term frequency, the number of times a particular word is being used in all of your data sets. IDF is inverse document frequency. That's like if a word is used rarely, like for example, 256 GB or something is used rarely, but then that's a catch point for it to tell it's an SSD, right? So inverse document frequency will catch the words which are used rarely, but have a big effect on predicting if it's predicting the class.
Got it. Yeah, I know. I've seen that before.
So once our text description would go through TF-IDF, it would have some vectors or imagine numbers, and then those numbers would go into multiclass classification for classifying if it's an SSD, SGD, whatever.
Gotcha.
And then, okay, now that's like the phase one. That's not actually very important. Like the phase two is once you get if it's an SSD or HDD or whatever, your main job is to extract attributes out of it, right? So your description is there, and then now I had to run NLP models. I don't know if you've heard of named entity recognition, NER.
No, that's new to me. New name.
Okay, so what? Yeah, so for example, our multiclass classifier tells the description is a processor, right? On top of that, I run NER. The job of NER is to, from the whole description, extract features. So one model is trained to extract the brand. So one model will just tell you if it's an Intel or AMD. Another model is trained to extract the speed, right? So it'll tell you 3.3 gigahertz, 5 gigahertz, whatever. That's the model's job to extract. And if it doesn't have any gigahertz, its output should ideally be blank, right? So on top of the whole description, this model runs to extract attributes and put them into buckets. And now if you combine the two, right, phase one and phase two, and then I deployed it on like an internal site within Dell for everyone to use. So person goes to that site, uploads a workbook like Excel or CSV or whatever, and then it'll have like 10,000 rows of descriptions. It's just a part number description, that's it. And then once he runs that, phase one will run and it'll tell that description belongs to which part. And then all these tabs, there'll be a tab for SSD, HDD, processor memory in the output. So the output he'll get is the differentiated tabs and then the attributes in every tab. It's going to tell that these many descriptions are SSDs and this part number, this description had was in Intel, 3.3 gigahertz, blah, 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 blah. So this happens in like 15 to 20 seconds for like 1,000 or 10,000 rows.
That's pretty cool. Yeah. Thanks for doing all that.
I know, and it's a little complicated.
Yeah.
It took like 3 or 4 months for
I know the hard part.
Figure all this out.
The hard part is always like explaining it. Like, yeah, I built this super complicated fucking monster of a model, and then how do you like sell it? You know, how do you like interpretability, explainability?